Here are some of the consequences of the mean value theorem. All of these are actually pretty clear just by common sense and geometry, but the mean value theorem is how you would prove them algebraically. So first off, let f and g be continuous on the closed interval and differentiable on the open interval, which means that the mean value theorem applies for those functions. The first consequence, if f prime of x is 0 for all x in the interval a to b, then f has to be a constant function on the closed interval ab. So if the slope is always 0, the graph is always going like this, and the graph is constant. Again, easy to understand geometrically, but analytically you need the mean value theorem to prove that. 2, if f and g have the same derivative for all x in the open interval ab, then f has to equal g of x plus k for some constant k. That just means that f and g just differ by a constant. Like if I sketch that out, that means that these two graphs have the exact same shape. Like if that's f, then that's g. The only thing that separates them is some constant k. Because same slope means same shape. 3, if f prime is positive for all x in the open interval, then f is increasing. If f prime is negative for all x in the interval, then f is decreasing. This is only valid as long as your graph is continuous and differentiable. But again, it makes sense. F prime decreasing means the slope is f prime positive means the slope is positive, means your graph is increasing. F prime negative means your slope is negative, the graph is decreasing. These two give us easy ways to test if a function is increasing or decreasing. Find the derivative and see where it's positive and negative, and that tells you where the graph is increasing, decreasing. We'll do some examples of that later on. Just to show how the mean value theorem proves this, which, by the way, I think it depends if I do it this year, but I have in years past. The proof of one of these will be on the problem set for you for next week. So you'll be expected to prove one of these on your P set. I think, as long as I give that proof again. Here is the proof of one. It actually is longer than I thought it was going to be. So the first consequence just says if f prime is if f prime is 0 for all x in the open interval, then f is a constant function. So the first step of the proof would be to just restate this. Let f prime be 0 for some continuous and differentiable function f, etc., etc. Next, consider some fixed but arbitrary x value in the interval from a to b, where it can't be a, but it can be b. So x is a just random point in the interval a to b, but it's fixed. Once you choose x, that's what x is for the rest of the proof. And consider the interval from a to x. Now, f was continuous and differentiable on the closed interval a to b, which means it also is continuous and differentiable on any subinterval of the interval a to b. And since a to x is a subinterval of a to b, we know that the mean value theorem has to apply on the interval a to x, because we have differentiability and continuity. And that means that the average slope from a to x must be equivalent to the exact slope for some point c. But f prime c has to be 0, because the whole point of this is that f prime is 0 for all x values. So f prime of c is also 0, since f prime is 0 for all x, which means 0 equals the average slope from a to x. But this quotient can only equal 0 if that's 0, right? Because we know that x minus a isn't 0. Therefore, this has to be 0. And the only way for f of x minus f of a to be 0 is if those two values equal each other. And since x was arbitrary, this same logic applies to every point x in the interval a to b, which means for every point in between a and b, f of x equals f of a, which means it's constant. The function always equals the same y value. So again, if you do have to do a proof of one of these consequences, use this as your guideline. And again, don't forget the Stellar site. On Stellar, I have the lecture notes posted, and I have this proof proof typed up. I think I'll do one more of the proofs just to kind of give you a guideline for if you have to do it for your P set.